So I'm sure if you're here watching this video right now, you've probably thought to yourself, or you probably saw the title of this video and thought to yourself, what is the integral of secant x? And today I'm going to show you two different methods of integrating this function. The first one is going to require manipulation. The other one is going to require a special trick. So to begin with this integral, let us just use the identity that secant x is equal to 1 over cosine x. And then this is still with respect to x. So starting off from here, we can just use the property of multiplying everything by 1. So I'm going to multiply everything by cosine x over cosine x, which in this instance will result in this. And I have changed nothing because this is still equal to the integral 1 over cosine x. But we can just do this because, algebraic manipulation. So from here, let us use the identity that sine squared x plus cosine squared x equals 1 for the cosine squared x in the bottom. Then, therefore, cosine squared x equals 1 minus sine squared x. If we do that, we're going to get cosine x over 1 minus sine squared x with respect to x, right? From here, we can use u substitution. So let's make u equal to sine of x. And as we can see, we have cosine x dx right here, right? Du is equal to cosine x dx. So we can just make this all equal to du. Let us start off right here. So now this integral will become du over 1 minus u squared. Now, if you can't tell, this integral looks like a difference of squares. The only thing that's stopping it from being a difference of squares is the fact that there is a negative sign in front of the u squared instead of in front of the 1. So what we can do is we can rewrite this integral using manipulation to be du over u squared minus 1. And from here, we can rewrite this integral to be equal to du over, all right, u plus 1 times u minus 1 using the difference of squares. And from here, as you can probably tell by now, we can make this, partial fractions. You can use partial fractions to solve and simplify this integral. So let me just write this out for you. 1 over u plus 1 times u minus 1 is equal to a, unknown, because, we have to figure that out in a second, over u plus 1 plus b over u minus 1, which all ends up simplifying to 1 equals a times u minus 1 plus b times u plus 1. If we let u equal 1, we will get 1 is equal to 2b. In other words, b equals 1/2. If we let u equal to negative 1, we will get 1 is equal to negative 2a. In other words, a is equal to negative 1/2. So now let us take this and rewrite this. Now this integral of this, what we originally had was du over u plus 1 u minus 1 and we can set this equal to the negative integral of a, which is negative 1/2 over u plus 1, I believe. Yes. Minus the integral of 1/2 u minus 1. And everything is with respect to to u. So let's not forget to do that part too. Now, we can simplify this first integral right here. Let's take this one down here. We can simplify the negatives and take out the 1/2. So then this becomes du over u plus 1 minus, and we can simplify this other one too. So now we have these two integrals which are solvable. The first one is going to become 1/2 with ln absolute value of u plus 1. Subtract 1/2 ln absolute value of u minus 1. And don't forget your constant. We can simplify this even further though, and make this 1/2 times ln absolute value u plus 1 minus ln absolute value u minus 1. We can take this one step further, and because of our logarithmic properties, this can just simplify to ln absolute value of u plus 1 over u minus 1. And then don't forget your constant of integration. Now if we take u, which we had originally equal to sine of x, and substitute that back in for u, we will end up with 1/2 ln absolute value sine x plus 1 over sine x minus 1 plus, plus c. And that is our first method for solving this. We have another technique that we can use to integrate secant of x. It also requires you to multiply the entire integral by 1, but instead of using trigonomic, identities and, making secant equal to 1 over cosine x, we're going to multiply the numerator and the denominator by secant x plus tangent x. And everything here should be with respect to x, but I cannot write it in that space. So let us rewrite this integral down here. If we distribute this, we will end up with secant squared x plus tangent x, secant x over secant x plus tangent x with respect to x. What we can do now is we can make u equal to secant x plus tangent x. And then if we use this, then our derivative du will have to be equal to the derivative of secant x is secant x tangent x, and the derivative of tangent x is secant squared x. And then all of this is with respect to x, which I don't have enough space to write there. Now, if you notice, secant x tangent x and secant squared x is in our numerator, and dx is as well, obviously. And so therefore, this is all equal to just du. And since this is u, this will be equal to our u. So rewriting this integral, we will have the integral of du over secant x tangent x, which is our u. In other words, this integral will end up simplifying to ln the absolute value of u plus our constant. Now, since our constant u was secant x plus tangent x, the final answer will be equal to secant x plus tangent of x plus c, which is probably the more commonly used integral. However, it does require a technique that which, some people may not see. The other one is more intuitive in my opinion, but regardless, you really don't have to know how to integrate this. It's just something that's interesting to solve if you have the time to, or if you, just want to look into it and try and solve it by yourself. That's it.